Hey guys, welcome back to Tech Canon. This is chapter 3, the interview. In this chapter, we'll be going over two major parts, the behavioral interview as well as the coding interviews. I titled this Know Your Code just because I'll be going over the fundamentals for explaining your code to your interviewer. Let's get right into it. So, for the behavioral interview, there are two things that I like to highlight as crucial here. One of them being the prep. You need to be ready for any question that might come your way for behavioral interview, and I'll go into the most asked ones in the next page. And the STAQ-F method. This is a method I formulated, which is a variation of the STAR method, which a lot of people are very familiar with. The STAR method is a very popular answering style for answering questions during interviews. But I'd like to recommend this variation, which goes into more detail a lot more in the next slide. So, the behavioral interview. How do you want to prepare for this? There are so many ways to prepare for this, but the very first thing I like to tell people is to start off on a blank slate. What do I mean by that? So, one of the most common questions asked during interviews is, tell me about yourself. I know you've probably gotten this question asked so many times, and it sounds like a no-brainer, right? You tell them your name, where you're from, and a bit about your experience as well as education. For this question, I like to tell my interviewees to come in there with a blank face. What do I mean by this? So when I say a blank face, I'm talking about who you want your interviewer to see you as. I would expect that you would have done your research into what kind of person the team is looking to hire, just in terms of what skills you possess, as well as in terms of the team culture. You'd want to create a facade of some sorts. I'm not saying you should lie on your resumes. No one should do that. All I'm saying is you want to highlight traits of yourself that reflect the position that is being interviewed for. Pretty much what this entails is knowing who your interviewer is looking for and being that person during the interview. Next is know your technical projects. So when you're told to talk about yourself, I'd like to recommend starting from the top of your resume where you mention your name, where you are from, and get right into explaining your technical projects. You don't want to go as much into detail unless asked by your interviewer, but you want to definitely highlight what you did in that project and what outcomes were a result of that project. I'll explain more about this in the STAQ-F method. Now, last but not the least, definitely, you want to try to stand out during your interviews. You want to make sure you leave a lasting impression on your interviewer. Your interviewer is probably going to interview a couple more candidates, 20 maybe, it could be even more. And you want to leave a lasting impression so they remember who you are. To stand out here could mean explaining in technical details what one of your projects entails when asked to do so, or it could even just mean having an uncommon hobby when asked, what do you have any hobbies? Especially if you share a hobby with an interviewer, that always helps to keep your name at the tip of their tongue. And last but not the least, one very good way to stand out during these interviews is to ask uncommon questions. So when your interviewer comes up at the end and asks, oh, do you have any questions for me? You want to throw in questions that you feel most people would not ask but are still relevant to the role. You want to make sure you answer your questions boldly and as confidently as possible. Confidence will go a long way in these interviews. Your interviewer likes to see that you know what you're talking about, but more importantly, that you are confident in your answer. Now, moving on to the STAQ-F method of answering questions during the interview. Like I said, this was a method I formulated as a variation of the STAR method, which a lot of people are familiar with. What does the STAQ-F stand for? S is for situation, T is task, A is action, Q is quantify, and F is for future. So, for situation, you want to pick a situation that expresses a challenge you faced either at a company or while working on your personal project. A great example of a situation at a company would be, say, a company was targeting a certain market size of maybe 1,000 users in a certain area, but they noticed that the signups they had for customers were only around 10 out of 1,000, and they were expecting a lot more conversions. Um, that is a challenge for the company and a challenge that you could explain that you took on yourself. Next, you want to identify what tasks you can take to help remedy the situation. In this case, a task here could mean doing market research to figure out why the conversion rates were low, or could even go as far as saying after doing market research, we identified the major reason why customers were not signing up was due to the cost of onboarding new customers for the company. Say they had to sign physical documents and these had to be transported back and forth, and this reduced the conversion rates for the clients. Next, action. This is straightforward. You just want to explain what action you took to help remedy the situation that was previously mentioned. So an action here could be I created a web application with a form that helps customers sign up online and sign their documents online versus the old method where they had physical forms that had to be picked up and delivered to a separate location and then signed, and this reduced the time to onboard new customers. So now quantify. This is very crucial. This is one of the variations I made to the STAR method. You want to be able to quantify your impact. You want to be able to quantify the results of your action. Say you created a web form that helped reduce the onboarding time for new customers. By how much did it help? Did it reduce the onboarding time by, say, half an hour, by a couple hours? You want to express that. Did that lead to having 50% increase in customer signups after your solution was implemented? You want to express that here as well. Now for future, you want to definitely explain what you could have done better if there were any shortcomings during your project, or if you don't have anything for what you could have done better, you could always talk about what you can do in the future to even improve the outcome of your application. Say in the example we gave where there was an issue with customer onboarding time and you helped resolve that with forms. A good example for future could be extend the existing application to onboarding new employees as well. So that reduces the time to onboard new employees and hence save the company even more money on both the customer side as well as the employee side of things. Next section is know your code. So in this section, I'm going to be going over two crucial concepts to knowing your code and being able to explain it. The first one being time complexity and second space complexity. Time complexity. What is time complexity? In its simplest terms, time complexity is how much time it takes your code or algorithm to run. Now, how is this measured? A very common way to measure time complexity for algorithms is using the big O notation. What is the big O notation? Big O is simply a language metric we use to explain the efficiency of algorithms. You want to make sure you master this, as it's a crucial concept and would be crucial going forward. So I'm going to explain big O in time complexity using these three cubes. Say, for example, you had to move these three cubes from side A to side B. How would you do that, and how would you express that in time complexity? The simplest solution would be to pick up box 1 and move it over from point A all the way to point B. Pick up box 2, move it all the way from point A to point B, and then pick up box 3 and move it all the way from point A to point B. So if we were to express this in time complexity, we would say it took you 3 trips to move these 3 cubes. Now, let's say you had a trolley or a cart, whatever this you want to call this, at your disposal to move these 3 cubes. What would be the most efficient way to move these cubes from point A to point B? Now, the easiest thing to do here would be to load up these cubes on the cart as such, and then you could easily move that cart now with the 3 cubes from point A to point B. Now, in terms of time complexity here, we would say this took you 1 trip as opposed to the previous method, which took you 3 trips. So if we were to explain this in big O complexity, we would say this first method took you 3 trips and there were 3 boxes. So it's fair to say that the number of cubes using the first approach is always going to be equal to the number of trips you would take. Now, using the second approach, as long as you have enough space on your trolley, say the maximum number of cubes you could have is 10 and your trolley could fit 10 cubes. In this instance, your runtime complexity, time complexity would be O of 1, meaning no matter the number of cubes, as long as they are less than 10, the time complexity to transport those cubes would always be O of 1, which is constant time. Now, these are very common runtimes which we would see in runtime complexity when explaining your code, but I'll not go into detail on all of them. I'll explain some of them going forward. These are a few other not as common. Now, explaining O of n. Say, for example, just like in the previous analogy I gave, for every element I that exists in a certain array, an array containing a couple of elements, you want to print out every element. This is a code snippet in Java, by the way. If you create a for loop's job is to go through every single element within your array. In this instance, say you had in your array 1, 2, the elements 1, 2, 3. It would print out 1, 2, and 3 for you on a new line. So the runtime complexity of this would always be O of n, because for every element in the array, you're going to print out exactly once. Now, let's look at this example on the right. You have 2 for loops, one running through an array printing out every element, and you have a second for loop with an array printing out the element's value plus 10. So one would be quick here to say that the runtime of this algorithm would be O of n plus n, which is also O of 2n. Now, this is not entirely wrong. However, for the sake of interviews and explaining runtime complexity, we would drop the constant. In this case, the constant being 2. So say you had O of 2n, here you would just express as O of n. So if there was a third for loop, as long as they were happening sequentially, that one for loop happens n times, another n times, the next one n times, you add it up, 3n would still express that as O of n. Now let's look at another common example of runtime algorithms, O of n squared. In this example, we have a for loop that wraps another for loop. So in this case, for every instance of the top for loop, there will be n amount of instances happening at the child inner loop. Now, what do I mean by that? For example, let's say our array had 3 elements, 1, 2, and 3. So when we start at the top for loop, the very first number we have is 1. And then for every time I equals 1, in the next loop, we'll be calling the elements of the array for the occurrence of the first number in the array. So in this case, we would have 1, 1, 1, 2, and 1, 3. Then we move on to the next element at the top for loop, which is 2. Then for this one again, we would go into the child loop and call 2, 1, 2, 2, 2, 3. For the third element at the top for loop, we go into the child loop again and call 3, 1, 3, 2, 3, 3. Now, if you look at this, how many instances do we have after the double for loop? We have 9 of them, which is equivalent to 3 to the power of 2. So this is how a double for loop will be expressed as O of n squared runtime. Now let's take a look at this other example to the right. We have pretty much the same thing we have from lines 1 to 5 that expresses a double for loop. And then we have after that another loop that just goes through every element in the array one time. So one might be quick here to say the runtime of this algorithm would be O of n squared, which is the runtime for the lines 1 to 5, and then O of n, which is the number of elements in the array n for the code on lines 7 to 9. Just like on the previous example where we drop the constant, in this case, whenever you have an algorithm that expresses the summation of one runtime that is superior or greater than the other, in this case, n squared is of higher complexity than n, we can just drop the n since that would not matter in terms of the big O's worst case complexity. So in this case, this algorithm as well can be expressed as O of n squared, since the n itself has little to no effect, and n squared would be the major bottleneck for this algorithm. Now another example here is where we have 2 for loops, one that goes through array X and the second one that prints out every element in array Y. Notice that these two, in this case, these two arrays are different arrays. So it would be wrong here to just simply say it is O of n, even though it is going through just the number of elements. In this case, since array X and array Y could have different number of elements, the most accurate way to express this algorithm is O of X plus Y. Now, same goes for the double for loop like we looked at previously. Array X could have 1 to 2 elements, and array Y could have way more elements, maybe 10, 20 elements or less. So in this case, you can't simply say O of n squared since it's not n multiplied by n. In this case, you have X number of elements on the top loop and then Y on the bottom loop. So the runtime is best expressed as O of X by Y. Space complexity. This is simply a way we express the amount of memory required for an algorithm to run successfully. For example, in the analogy I explained previously, where we needed to move 3 cubes from point A to point B, given that we needed a trolley of size 3 cubes, hypothetically, the space complexity could easily be expressed as O of n, meaning an array of size n, or a trolley of size n that could handle 3 cubes. Quick summary of everything we went over in chapter 3. The behavioral interview. Prepare for the interview by knowing what the company is looking for and be who they are looking for. Be confident. STAQ-F. Keep this at the tip of your tongue. Situation, task, action, quantify, future. Now, for knowing your code, we also went over space complexity as well as time complexity and how to express this using big O notation. Thank you, and that ends chapter 3. Look forward